Let us begin implementation today. Implementing Postgres and creating database for our purpose. So when it comes to implementation, we need to consider whether we should go for default configuration or whether we need to go for custom configuration. So default configuration itself, we can get a database server which we can use it for our purpose. So when we say database server, we'll get both the database as well as the service. We can use both database and service, part of our database server. We can do with default configuration itself. If required, you can also go for custom configuration. So customize the configuration and you can use it for your purpose. So either way it is possible. So initially we'll go for default configuration. Means all completely will go for default configuration. As we progress, we'll see how to customize Postgres for our purpose. Now it comes to implementation. So we can consider four stages. So one is operating system level, the other is Postgres software, third one is Postgres instance or service. Okay, so fourth is Postgres database. So here, part of our learning, we're going to use operating system as I'm going to use Oracle Enterprise Linux 6 and Postgres 12. Okay, so it is compatible, it works. So as I said, okay, our objective is learning Postgres rather than trying with various options of implementation. So my suggestion is, okay, you can go for same configuration for your purpose. So Enterprise Linux 6, Postgres 12 will work fine. And when it comes to taking care of your implementation, so we need to take care of it in first in operating system level. Hardware level, the commodity servers are fine for us. We can use commodity servers available with us. We can use it. It can be your bare metal server or virtual machines. Or if you take in normal way, it can be your laptop, directly you can use it, or desktop you can use it, or else within that you can use virtual machines also. So you can build virtual machine for your Postgres purpose and you can use it. So then you need to take care of your operating system level. So prepare your OS. Okay, prepare your OS means take care of necessary configuration within your operating system. So particularly about the packages required and the space. So then the resources like RAM. So you need to take care of preparing OS level. So then the next thing that we have to do is you have to build the RPM repository. So that you will be able to get software of Postgres. Okay, in our case we'll use version 12. So phase 2. So we'll go for installing Postgres client. Then we'll install Postgres server. Both client and server will install. Okay, so part of that is our second phase. So install Postgres software, both client as well as server software. Then we need to build the service. Postgres service we have to build. Okay, so configure service. So once you configure service, you can the third step is that, okay, so phase. Fourth phase is initialize your database. When you go for initializing database, you get three databases. One is Postgres default name, then is template 0, then you'll get template 1. Three databases you'll get initially. So this is what you initializing your database means. When you say Postgres, whenever you connect, you'll be connecting to Postgres database that is created. Template 0 is created, which is a template database. Template 1 is created, which is a template 1 database, which is referred by other databases to get created. So initially, when you initialize database, you get three databases. Prepare your operating system, build RPM repository. Okay, so ensure that you're building a RPM repository. Then go for installing Postgres client software first. In our case, version 12. Then install Postgres server, again version 12 itself. Then configure your service, initialize your database. So we will do it in these steps. For that, I'm going to use Enterprise Linux 6, Postgres 12. So part of our implementation, let us look into the steps of doing these activities. Okay, so we'll go for standalone implementation. So first step of that implementation is prepare operating system. Prepare operating system. When we say preparing operating system, so ensure resources like the disk space required, then the RAM required. You ensure that okay, you got sufficient amount of resources. Then you need to take care of your networking configuration. Networking configuration. So either go for DNS or etc host file. So in our case, we'll go for etc host file, but recommended is DNS, so that you can refer your server with name actually. So go for etc host file. And one more requirement is you need to have internet connection for getting softwares. Okay, getting softwares. We can also go for RPM based implementation, which is custom configuration. So if you want to implement in a standard way, you can go for you need to have an internet connection to your system. So whether you use it laptop or desktop or okay, so virtual machine, so you should have internet access. So this is one consideration. Okay, so here when we say resources, learning purpose wise, if you have about 2 GB, okay, so or more of RAM is sufficient. Okay, and your mount point doesn't need much space because Postgres software is not very big actually, it is quite small. So you don't need to worry about much resources. So that is one of the advantage. Unlike traditional RDBMSs where they are bulky, so 4 GB, 5 GB, 6 GB, so it is not so much. It will be installed as a package actually. It will be installed as a package into your operating system. So when you build database, depending on the amount of data you might store, so even that is also not big. Based on the requirement, okay, you want to create smaller databases. As and when you create, okay, you need space actually. So you don't need to have much space. Okay, so if it is about a couple of GBs is sufficient initially, because your software is package. Okay, will be installed as a package. So second step is build RPM repository. So in other way, you can also call it as M repository, M repository. You have to build that repository. This is the first step you have to do, part of our implementation. So repository is built, means it will maintain which are those software that you installed. So and even it will come to know that whether you already installed Postgres 12 client and server softwares. Then install client software. First you install client software, then you install server software. So for that we're going to use M utility. Okay, connects to the repository and it is going to get that softwares. Next is you can perform custom configuration, which you want to skip as of now. We will not do any customization. As we have decided to go for default configuration, so we will not do any customization. So in case if you want to do it, so you have to perform custom configuration here. So then you have to go for initializing your database. Okay, initialize your database. See, part of initializing database, so it is going to do two things. One is it is going to build your database and also create a service. So both will happen automatically. Okay, both will happen automatically. So here initialize database, you'll get database and service got created actually. Then ensure that okay, you want to automate your services so that when server starts, so your Postgres service is started automatically. So this we can call as auto start of your Postgres. Then you need to start your service. So current running, you have to start it actually. Otherwise, you have to restart your server. You have to restart your server. Instead of that, so this auto start is for next restart. And currently, you have to bring up your service so that you can access database. So then start your service. Then verify information. You have to verify the information, particularly. So you have to verify software installed. You see services created. Okay, so we'll check for that. Processes running part of our service, and files that are created part of our database. So 4 things we have to verify. So we'll start from first step. As we progress, okay, we'll see other steps. Okay, so a simple way, quickly to recap: prepare operating system, ensure that the sufficient resources are available, and networking wise, we better go for DNS, or else at least we configure it is host file. So second thing is you need to have internet connectivity for the server in which you are going to install Postgres software. So then install and build RPM repository, M repository, then install client software, then server software. So you have to install both. So then you have to go for configuration. If you want to do any custom configuration, you have to do that. Then initialize database, so you get both database and service. Then automate your service so that next restart it will get started automatically. For current, you have to start the service. It is not started just when you initialize database. It is created only. You have to start that, then verify the information. Now, when it comes to here, why we have to install server and client. Server is for your Postgres server created, and even you work as a client as an administrator. You work as an administrator. For that, you need to have client software. So, somewhat similar to as you're going to use SQL Plus to work with the databases. So here you need to have the platforms, okay, which I'll explain. So for that, you have to install client software also. So these two is a part of our software. So then customization is up to you. So then this is part of your initializing and starting your services. Then verify the information. Now part of our implementation, we're going to do our activity as root user. But okay, part of our implementation, internally it is going to create user by operating system user by Postgres will be the owner for two things. One is for processes, the other is for database. Means so database server is owned by Postgres. Both database as well as services are owned by Postgres user. So Postgres is an operating system user, at the same time is a super user for database. So in general, you can call it as admin user, but basically super user for database. Operating system user is a super user in database. So as I mentioned, so we'll go for Linux 6 or Oracle Enterprise Linux 6 and Postgres 12 version we are using. So this is a consideration with respect to implementation. So we'll follow these steps of implementing now. So I'll connect to server and we'll do from step number 1. Okay, so connecting to server. You're connected to a server. If you see host name is Tunga. So IP address wise 200.168.1.71 is the IP address, and it has got two interfaces. So one interface is what we have configured, this IP address. So ensure that it is been added to your DNS configuration, or else at least for etc host file. Okay, so IP address must be mapped to your host name with and also to alias name. IP address, alias name, and host name. So IP address is in our case 200.168.1.71. So and alias name is host name dot domain name and host name. So we have to map this. So must be configured. So ping self ping. I'm doing self pinging. Okay, so it is able to ping Tunga. So we're able to ping. So means all IP addresses are pinging. So this is one of the fundamental requirement. If you configure DNS, fine. Otherwise, at least it is yours file you can use, which is treated as local DNS configuration file. So etc host file is considered as local DNS configuration file. Look, you can configure that. It will act as DNS actually for local server. So next to this, okay, so let us verify. So the second interface is I'm using it for internet connectivity. So let us ping and check whether we got internet connected to this server. Okay, so it is pinging. This we are able to connect and work with internet also. So this is the fundamental requirement. And if you check for the disk spaces, so got many mount points. So I'm going to use one mount point df minus HYIS. Okay, so this mount point we're going to use in case you want to customize. So, but as we have decided to go for default configuration, so it is going to place the file center /var actually. /var is the default location for your files. So, and I've got 1.1 GB. Okay, so if you got a GB of space is sufficient initially. So here /var is treated as a variable file system. So meant for storing logs and is also default location for our Postgres when you go for default configuration. So initially we'll go for that. So ensure that if you got bigger, it is fine. You can use var itself, but okay, it's not mainly for the databases. So databases you place in your own mount points with custom configuration. As of now, we'll go for default configuration because of this it uses var actually. Ensure that you got sufficient space in var. So in our case, I've got about a GB of space is sufficient as of now. Because we'll not go for a very huge database. That is why okay. This is required for database basically. Will be the mount point for your user at the same time location for database. So it's not for your software because software is installed as a package. Installed as a package. So and all those executables will go to USR. So we've got sufficient space for maintaining USR. So if you go for top, so it'll show the amount of memory you got. So got around 2.5 GB of memory, which is sufficient for us actually. Okay, which is sufficient for us. For learning purpose wise, we don't need bigger memory. So unlike the standard RDBMS, like if you take Oracle, it expects 4 GB of RAM. So here, Postgres based somewhat similar to NoSQL databases, big data technology databases itself, because even with commodity server we can use it, and also with lesser memory we can use it. And then when we start using, we can also increase the configuration so that we can use it for our purpose. So this is what the case consideration with respect to the preparing operating system as of now. Okay, so now let us build the repository, RPM repository or M repository. So I'll use this terminal. In other terminal, let me check. Okay, I got one more terminal. So M repo list. We show the repository list. Whichever the repository is available, it is going to display it. It's taking little time. So anyway, parallelly, I'll explain about the so M install a package. Okay, yum install. So you have to specify the location from which you have to get the repository. So HTTPS download Postgres. Okay, so the link is there, Enterprise NX 6686. Okay, so for Postgres, for Red Hat, okay, so Enterprise NX also is Red Hat itself, repo latest, no archive RPM. So it is going to get that. Okay, let this complete. Okay, so now we can see the repo list. It is showing the repository list. Now we need to get a repository for our Postgres purpose also. We have to build it, update it, so that it can fetch these softwares later when we install the softwares actually. So yum install the repository we are installing now. Repository we are installing. For this, you need to have internet connectivity. So it's prompting us to install the repository. See, even though it says Red Hat, it is for Oracle Linux. Whereas all Linux, like if you take CentOS or Oracle Linux, the source is Red Hat itself. So you say yes, install this package. Completed. So repository, it has built repository. So what is that you have to do is use yum. So yum install the RPM. So Red Hat repo RPM for Postgres. So it is going to install the required packages. Okay, so you specify yes, you want to install it. It got installed actually. So you need to build this repository. So the important step before installing your client and server softwares. So you can check for the repo list again. So you can see we got Postgres related. Okay, so repositories. In our case, we'll be using 12. Okay, Postgres 12. So it has been updated now. It has been updated. Now we need to install. See, initially when we ran that, it was not there. Postgres was not there. Now it is there available. It is there available. Now we install the package repository. So it has been built now. It is installed, and you can when you check for the repo list. So the version we're going to use is 12. Okay, so basically it says for RHEL and CentOS is also compatible for any other operating system which is using Red Hat source itself. In our case, Oracle Linux also. Okay, so now let us move on to the next step. What we did here is we installed the repository package. Now we're going to install yum install PostgreSQL 12. So when we say PostgreSQL 12, actually this is client software installation. First you have to install client. Okay, so client install software. Again, yum install PostgreSQL 12. It is going to install the required package for the version you are using. As I said, we are using version 6 Linux wise. So you can see it is going for that. x86 is your system, so it is not server. Okay, so it is a commodity server. So yes, install package. So it is going to install 2 packages. Okay, parallel we'll check for that. Okay, whether it is there already kind of thing. RPM QA grep Postgres 12. So some packages might be there available, part of your OS installation, if you're choosing the Postgres software. So as of now, it is not showing anything. So we'll say install m PostgreSQL 12. Basically, it is going to install client software. Okay, so for that, whichever the dependent software, it is also getting installed. So when you do installation without using m manually using RPM, so you should take care of all these packages, compatible packages, which can be done. It is not that we can't do, we can do it. So we'll say yes. So it installed PostgreSQL 12 and lib also, which was a dependent software. Let us verify. Check with PostgreSQL 12. Okay. So it has installed PostgreSQL 12. It has installed now. PostgreSQL 12. This is your software, client software, lib actually. So now we'll go for server software. So we installed the client software. So similar to that, we will use server, -server. If you use that, that is sufficient. Yum install PostgreSQL 12 -server. Now it is installing the server. So we'll say yes, install it. The dependent packages are already installed. So no dependent packages are installing now. So completed installing server software also. Now let us verify that. So you can see we got server also. Earlier we had only client and lib, which got installed in the previous one. Now we got server also, we have installed it. So means adding a package to your these are operating system packages actually is been added. It's been added. Now let me switch to the presentation. What steps we have covered now is we have done preparing of operating system. Then we installed the repository package. Then we installed the client software. Then we installed the server software. So now you need to perform custom configuration, which will take up. Okay, as I said, we will not go for any custom configuration. We will go for 100% default configuration itself initially. Now we'll go for initializing database or database server. So means when you say initializing database, you get database as well as service. Database as well as service, which I'll show that again. So now initialize database is what you have to do. Two major steps basically. One is installing the software, including the RPM. Okay, installing the software. Second one is initializing your database and configuring it. So then later we're going to start also. First we'll initialize database now. So connecting to server, we'll initialize our database as a service PostgreSQL 12 initDB. First time only once you're going to do this. Part of this it is going to do activities in both the layers, operating system layer as well as in database layer. So which we are going to learn as we progress. Anyway, we are initializing database. When I say database server. Server contains two components. One is service, one is database. So both will get initialized. So initializing database now. Service PostgreSQL 12 init DB. Completed. So if you look into this, we have built our database. So we don't need to take so much of time as we take it in our other standard DBMS. They take a lot of time. So for implementation plus database, now it is there ready actually. Let us verify for the informations. Let us verify for the informations. So use another terminal available. We have installed the packages which we saw. That is for your software wise. Now let me check for file, password file. This is for operating system user. So we got a user by name Postgres now. Okay, username by Postgres. Let me show completely. This is the last user that is added now. Actually, it has been added now. Postgres user is created. ID is 26. Group ID is also 26. Means it has added to same group. Username itself is group name also. This is for Postgres server. So usually what we do is we give this is the user home directory. User home directory we give mount point and the user name as mount point. Okay, user home directory. But here you can see is a different mount point and bash shell is used by the user. The Postgres user is created. Postgres OS user. So here Postgres has got one consideration. So username is Postgres, database name is Postgres, service is also referred by Postgres itself. Okay. Within database we'll have a database Postgres. Within database we'll have a super user Postgres. Okay. So don't get confused with this. So as we progress, so you'll get clarity actually. Now we got operating system user Postgres, who is the owner of the software now, and database also, owner of software and database. Now ps minus ef grep Postgres. See, your services are also owned by Postgres user and also service name is also Postgres. As of now, it is not there. Okay, so when I said initialized database, it is initialized only. So then after that, you have to start the service. Till you start, so services will not be available. So now currently it is not running. Now we have got two things. One is you have to do configuration so that next restart of your server, Postgres service will come up automatically. And now currently also we have to start because now it is not running. We have to start it. We have to do two steps actually. Okay, so one is configure the service so that okay, it is started automatically whenever the server is started next time. Second thing is start the service also now. So let us switch to the presentation. There you can see that. So what we did is now we initialized also. So initialization is also completed. So it has initialized database. Service is also initialized, but it is not started actually. Now you configure service for what? Auto start. Means next time when a server starts, so Postgres service should start automatically. For that you have to automate it. Then you have to start the service manually. Before you verify, we have to do these steps actually. Let us do that in our server. chk config PostgreSQL-12 list actually. You can just list it. You can see it is off. So this is your service in which run level. See, 0 is run level. These are called as run level. So if you check for current run level, it is always 5. N means networking enabled, level 5. So this is your run level. And you see, Postgres is off actually. When we have implemented, it is off. So in which level it should start, okay, you can decide that actually. Usually these 3 levels are the levels in which we can log in and perform our administrative tasks. But usually it is 4 and 5, 5 where we get networking services. 5 is the default one where we get all the services. Network mount points are available. Networking services will be available. Everything is available. So you have to do that. Okay. So now, if you want to do it in specific run level, you can do that. Or else, if you can just say on, it completed. Okay. If you list now, run level 2, 3, 4, and 5, it has become on. Means your Postgres, if you start to run level 2 also it is started, run level 3 also it is started, run level 4 is also started, and 5, which is the default one, it is started. Postgres service will be started by default in these run levels. Means being user, administrator, if you connect to any of this run level. See, because basically when we boot our operating system, we can boot a specific run level for specific purposes. So let us not consider why we want to go for that kind of thing. So default run level is 5. If you enable only for 5 also is fine. Or if you say on, it is going to enable for all the run levels where users can connect as administrators. So this enabling is for next restart. Current restart, still your service is not there available. Still is not available. You have to start that service actually. Then only get the service. Or else you can also check the service in the other way. So service Postgres status. You can check the status. So it's stopped. And you can check with processes also. Yes, -cf file grep Postgres is not available. Let us start the service now. Okay, let us start the service so that currently our service will be available for us. As you can check for the status, you can start it actually. So again, it is starting with all default configurations. So we are not doing any customization. Now we'll check for the status. So now it is running. Let us check for the processes. So you can see Postmaster is the first one that is going to start. And you can see all those whichever we discussed. Background process, some of the important background process, all are displayed here. And owned by which user? Postgres users. Though we initialized service as root user, so it has built Postgres user. It has created initialized database, but as Postgres user. So Postgres is used owner for both database as well as service. Database as well as service. So if you don't want your service to run, so we can check for the status is running now. Stop. So you're stopping the service. Check for the status. You stopped. Processors, if you check, they are also stopped. So we did two things now, part of our starting service. One is using chk config. So in run levels by default it is not enabled. So that next restart, if you start server, if you are not done enabling, So Postgres service will not start automatically. If you want to start your Postgres automatically when server starts next time, so then you enable services in run levels. Which run level? You can decide whether you want to enable it only in run level 5 also you can do. But if you just say on, it enables in all the run levels to which you may connect as administrator, operating system run levels 2, 3, 4, 5. So 0 is shutdown, 6 is reboot, init 0, init 6. Run level 1 is treated as single user mode. Run level 2, so user mode but without any networking services. Just you'll get the services, you can connect, or mount points, you'll get. And run level 3, you start getting the services, networking services. In run level 5, you'll have networking enabled file systems also. So enable it. After that, you can check that. List it again. So it shows that it's been enabled. So default is off. Postgres service will not start if server starts automatically or next time. If you enable it, now onwards, next time whenever you start the server, Postgres service will start automatically. Now, if you want to start manually, now we have to start manually because otherwise you have to restart actually. So for that, you can go for start actually. So currently it is stopped. You start it. It is running now. You can check for Postgres service. Processes are running. Now let us go to presentation again. Part of implementation. So what we have done is we configure the service so that auto start is enabled. Next time server start, Postgres service will start. And currently also we have started it. We saw the service running. Okay, service is running. Now verify the information. So software installed, services, processes. Anyway, we have seen that. Okay, we'll see it stepwise, and files also, which we'll see now, which is part of a database. So it means we have done software, service, and processes check. We'll do it stepwise so that we can also verify it easily. Then okay, we'll check for the files that are created and who is the owner of those. We'll use it for our database purpose. Okay, so let me switch to server again. So now verification will do RPM -QA grep PostgreSQL showing all those PostgreSQL available. Now if you say give only 12, it will show. Okay, so here, see by default when I install operating system, so we got 8.4 actually is there available. But in our case, we have installed the new one, Postgres 12. We'll use it for our purpose. So software is installed. Then we need to check for the service. Service PostgreSQL 12 status is running. ps-ef pipe grep Postgres. So processes are running. Now we'll check for the files. Okay, we'll check for the files. So software is installed, services is running. We have automated it also, and we have started now. After initialization, you'll have database and you'll have service. Service is started, and the processes are running, so that we'll be able to connect to database also now, because it can open database. Only through instance we can connect and work with database. Only instance can open the files of a database. Now let us do verification of the file, the files those are created part of our database. So we need to log in as Postgres user. We need to log in as Postgres user. You know that part of our implementation, the moment we say initialize database, Postgres user is created. So we are connected as Postgres user. ID, who am I? Echo dollar user, echo dollar home. So usually when we go for user home directory, it will be same name as user. So here is an exception. It says a PGSQL, Postgres SQL, under var. So that is why I said, okay, so var should also have some space actually. So you can see it was around 1.1 GB. Now it is about 100 MB it has used approximately. Now so we are connected as user by name Postgres belongs to Postgres itself. So this is the user home directory. And if you give ls here, you can see only one directory by 12. That is your version actually. Version. So under user home directory, you will have a subdirectory by version of your Postgres software. Under that, you will have data. Okay, so you will have data. So this is your data directory. This is called as data directory. Within database also we'll check later. So in this location, you can see subdirectories and files. So these are the subdirectories and files available part of your Postgres. So this is initialized whenever we say initdb. Whenever we say initdb, they are initialized. So and all are owned by which user? Postgres user belong to Postgres group itself. So means under user home directory, so we'll have version directory. Under that version directory, we got data directory. So this is actually called as data directory. This is the location for your database related files. One such subdirectory is base. Base is for your database. So how many databases will be created by default? How many databases will be created by default? Okay. Okay, fine. Okay. So all of you are right. So all of you are right. So now we can see here under base, we got three directories. Three directories for three files. Three directory for three files. So one number wise. Okay, so don't get confused. I'll teach you what is this. 1, 13,829, 13,830. So these are numerical value. Usually this will be always 1. This value will depend on the ID actually. So some of the ID that is generated. So three directories, subdirectories we can see under base. This is your base database location. We got three databases. For each database, you got a separate directory. Okay, so let us connect one of the directory here. 13,830 example. Under data directory, which is nothing but user home directory, version and data directory there is called as data underscore directory. Base, so the first base we are checking. If we give ls, so there are many files. So ls, I'll go forward count 302. So you got those many files in this directory 302. So just for example, I'm showing that. Means your database is ready now. So under data directory, you'll have all the subdirectories and files required for database. So here we got PostgreSQL.conf doesn't have any thing now because we are not doing any customization. So we are using all default configurations. So this is about implementing Postgres. So verification wise, we have to do 4 steps. Quickly we'll do it, a recap. RPM. PostgreSQL 12, I'll go for that only, specific. So checking the status of the service running. Checking the background process, they are there. Motion directory, data directory. So fast. So all 4 we are seeing. We got installed software, Postgres 12 version. We've started the service. We have enabled so that next restart also will get started. Once we start the service, processes are running, and in data directory, so what directories and files related to Postgres database. So this is about implementation. Now let us look into database, particularly database management. Part of that, okay, we're going to look into tablespace also. So later again, we're going to discuss tablespace in descriptive way. So now, database management. Part of that, okay, we'll look into some of the tablespace activities also. So what is it? Database is a place where data is stored. So unlike our traditional database, okay, here we'll have smaller databases. Whenever we initially implement and configure database, we'll have 3 databases by default. And whenever we store contents in database, so we physically it should go to a location in operating system level. So for that, okay, we need table spaces. Now, part of our implementation, what we learned is we have done operating system preparation. Okay, so hardware configuration, okay, and operating system preparations, we have done that. Like looking into the packages required, the resources required, the networking configuration we have to take care. We have done that in part of our operating system configuration. So then we installed Postgres software. So we installed 2 softwares, client and server software. So server software is required for your database and services. Client software is required for us to connect and work with the Postgres database. So when we say Postgres database, initially we initialize database will get created, and even instance is configured but will not be started. We have to start it so that the processes are started. And whenever we go for initializing database, okay, we'll get database, not just one database. So we'll get 3 databases by default. One is Postgres, one is template 0, the other one is template 1. 3 databases we'll get. So Postgres is the database to which we connect whenever we say we connect to database. So when we say we connect to database, we are connecting to Postgres by default. And whenever client has to connect, so whenever client has to connect, so client has to connect using platforms. So like for example, here we are using PSQL platform. PSQL is Postgres SQL, somewhat similar to SQL Plus. We need this platform. So this is available part of our client installation. So client software installation we get. So server side, server components are available, and client side, okay, so we need PSQL. Even we connect as administrators, we connect as client itself. But only thing is we connect as super user. And whenever you want to connect and work, you must always connect through instance service itself, instance or service, and you have to work with database, either with default databases or even with non-default databases. Whichever the database you want to work, you have to use instance itself. We can't do directly. Directly we can't connect to database because database is nothing but set of files in a specific location. We can't work directly. If those files has to be opened and okay, should be used, so we should connect to service itself. So we are going to use PSQL for that purpose. PSQL means PostgreSQL is a client platform to connect and work with the database. With PSQL, we can do two things. One is we can use PSQL commands or options to do certain configurations. So unlike SQL Plus, here we got a flexibility. We can also check for the database details also using PSQL commands. Or you can issue SQL statements. You can issue SQL statements as you do it in regular RDBMSs. Use SQL statements against tables available in your database. Again, default tables or the user related tables. You can decide that. Or else you can use PSQL commands also, which are very useful. So not only for performing customization of your PSQL, even to work with database also, we can use PSQL commands, or at least to get the information, we can use PSQL commands. PSQL is Postgres SQL platform. Now, whenever we want to connect and work, so we're going to connect as operating system user name Postgres. So, and we got database user by name within database also Postgres. Means when we connect to database Postgres, there's a database by name Postgres. So this is our database Postgres, and we got a user by name Postgres to connect to this database. We're going to connect as Postgres user, and from operating system level, whenever you want to work with this, okay, you want to connect as Postgres user itself in OS level. OS user is Postgres. Database user, who is a super user, is also Postgres, and there's a database by name Postgres. Because whenever in Postgres environment, whenever user connects to database, so it expects a database with same name as user. So similar to in operating system level, whenever we create users, okay, so generally home directory of the user is the same name as user, right? So generally, so if you take exception is Postgres itself now. So usually we do that. Whenever we are adding a user add, what is that we do is, whichever the user we are adding, name of that user itself will make as user home directory. Is it mandatory? Not mandatory. It's a practice actually. Same way in Postgres, we'll have a database user by name Postgres, and we can attach Postgres user itself and to a database by name Postgres. So it is Postgres, that's it. Okay, so OS user is Postgres, who is the owner of the software. Using that user, we're going to initialize databases. Okay, and when we connect to database, we're going to connect as Postgres user, who is the super user. Super user can do anything. And whenever we say we connect to database as Postgres user, we are connecting to database by name Postgres itself by default. So this is about databases. We can go for as many custom databases we can go for. So means non-default databases we can either user specific databases, means for every user of your database you can have a separate database, or else application wise also you can have separate databases. So usually if you take Oracle for example, we have got schema. So why we go for schema is applications related to a particular user is stored in that schema. Same concept here you can apply. Objects of an application which is normally owned by user, store them in a database with same name. That is what is the objective is here. Not only user name, even database name is also by default expected to be same as user name, so that objects of that user, maybe user specific or application specific, will be stored in the same database, which is name wise same as your username. That is what expected. So this is about database consideration. Okay, so let us further look into database details. So now we got a database by name Postgres, for example, or it can be by any other name also, or by any other name. So if you got a database, this is your database actually now. Logically, it is a database. Physically, it is a file. Okay, so database. Normally, when we take our regular databases, we say database will have files. Okay, so and in that, okay, we'll store objects contents. So here that is slightly different actually. When you got a database with whichever the name you got, for example, Postgres, so the files are stored under $pg data. Okay, so operating system level, it is an environment variable, pg data. Within database, it is a data directory. Okay, it is a data directory. Which is data directories? Okay, so which we have seen, I will further explain. PG data is the location in which your database files are stored. Under that, we got base directory. Base is the base for your database files, and within that, we'll have a subdirectory by OID of your database. See, for every database or for every component in Postgres, there will be a OID, object ID. With that object ID, a directory is created, and that is the location of your database. So that is the location. As of now, you take it as database location. You know that in Oracle database, for example, we store objects in table space, right? Same in Postgres also. But as of now, you want to store it in database. Okay, so whenever you store objects in database, it goes to this location. Which is that location? Under PG data. $PG means is an environment variable. Under PG data, base directory. So within that, you will have a subdirectory by number. This number is OID of your database. OID of your database. For every object, including database, there will be an ID. This is OID. So this is your OID actually. Example, I'm taking this value. This value may change. Okay, probably I think it is 13836 for Postgres or 35. We'll verify that. We can check the OID. OID is the object ID. That will be the subdirectory. Within this, we will have files actually. As many files. So we saw that 302 files. So separate files are created for your objects actually. So there will be many files in this. You take any database, so we'll have an object ID. Location of a database is default location is $pg data / base. Under that, object ID is the subdirectory. Within that, files are stored. By default, we'll have three databases. By default, three databases. One is Postgres. Then we have a template 0. Then we have a template 1. What is the importance of template databases? We'll see. So default, whenever you connect, we connect to Postgres database. Postgres database also is having an OID because that is also an object in your database. And location for the files of this database. Whenever we store something here, actually we'll go to this location. We'll go to this location. PG data base OID. So even in case of Postgres, actually objects will go to table space. We'll go to table space. Which table space? See, even for Postgres, we are not specifying any table space. We store objects in database. Very similar to you connect as user and you create data. So objects are they're part of that user. Same here, you connect to a database, create objects. Objects are part of your database, but actually they will go to a path of your database is identified by table space actually. So now, for example, we'll take Postgres database client using PSQL. We'll connect to Postgres database either to create table or to create index. Okay, so whenever they create objects, they should be stored somewhere. We know that logically it is part of a database, but physically it should go to a path. Which path it will go? It will go to the table space path. Which is the table space? Postgres user will use by default is pg_default. PG underscore default is the default table space for any database. Unless you mention a separate table space, for every database, PG underscore default is the default table space. And we got one more table space by name PG global. These are the two table spaces which are available by default. We'll see about table spaces later. But now, whenever we say we are storing objects, as client we connect to Postgres database, for example, and if you store any object in this database, should be stored in some location that will go to a table space. Which table space? PG default. So PG default is not a, it will not have files. So in Oracle database, for example, if you take, we create table spaces using a file, data file, one or more files. But here that is not the concept. For a table space, we'll have a location. For a table space, we'll have a location. If you take any table space, we'll have a location. So it is not just one data file. Okay, actually it is a path. Basically, it is a path. Okay, so whenever you go for a table space is a path. Within that path, files are stored here. As many files, depending on your objects. Now, which is that path for your default PG default? Which is default path for PG default? PG data. Okay, so PG data is nothing but home directory of your user. 12 is version. Data is the directory. So this is your, actually in database we call this as data directory. OS level is an environment variable. OS level is an environment variable. Database level is a location. We call it as data directory. So PG data is the location for your Postgres related database related files. Same way, data underscore directory is the location which data related, means database related directory files are stored. So one such directory is base directory. As name itself says, is a base for your database. Within that, we'll have a subdirectory by OID of your database. OID of your database. Now, Postgres is using PG underscore default. So location is for that is home path of user. 12 is the directory name. Data is the directory name. Under that, for example, 13836 is your object ID of database, or 13835. Object ID of your database is the subdirectory here. Means when you say we store table or index, it goes to which location? Which location? PG data location. Under that base, under that OID, subdirectories, OID. So OID is object ID of that database. In our example, we are taking 13835. So means your table which you created, test tab, the index that you created on that table. So in the form of files is stored under the path. Which path? Which path? PG data / base / OID of your database. If you take database wise, home path of user means data directory, under that base, under the OID of your database. So file is stored. If you create a new file, so by default, how many files are there? 302. 302. As and when you create additional objects, files will get increased in the default location. Whenever you go for a database, it will have a table space. It must have a table space. Default table space for database is PG underscore default. And logically it is a table space. Physically it is a location in which files will be stored for your objects. Which is that location? It depends on database itself. If Postgres is using PG default, means it is using the data directory, base, OID directory under that files. Under that file, that is your path actually. Path is defined through environment variable or data directory. So is the physical path, under that files are stored. So which we'll see. So you'll get more clarity about that. So this is what is default table space, PG default. But PG global is one more database, one more table space in which the dictionary objects informations are stored. Dictionary objects informations are stored, or in other way you can call as catalog objects informations are stored. PG global, catalog objects informations are stored. So this is about database and tablespace relationship. When you want to store anything in a database, actually you should store it in a tablespace. And tablespace is a logical entity. Physically it should go to a path. Which path? Your pg data slash base slash OID of your database, or data underscore directory slash base slash OID of your database. So OID of your database, not tablespace, right? OID of your database is the location. Tablespace will have a location, not a file actually. Inside that location, files will be stored. So let us look into these details within our server before we proceed to creating new database. So switch to server now. So I'm switching to server now, and we are connected as Postgres user. So basically, initially, after implementation, check for the status of your service is running. If it is not running, you have to start it. By default, it will start because we enabled service to be started. So using chkey-config, so that in at least in run level 5, it will be started automatically. Part of that processes are running. Okay, so they are available running now. And okay, so by default, we got an user in operating system level by name Postgres. So this is the default name. OS user Postgres is the owner of the software. So let us log in as Postgres user. Okay, so if you check for the user details, echo $user, and you check for the user home directory, echo $home. So usually it will be same name as username, but here Postgres is not using that name. Otherwise 4 names would have been same Postgres itself. But here OS username is Postgres, but the main point, our home directory of the user is PGSQL. Okay, PGSQL. Now under this we have seen earlier 12 directory. Okay, so under this we got data directory. So backups is there. We'll see that later. Data directory. This is your PG data location. PG data location. So let us check whether that environment variable is set here. PG data. As it is default configuration, it is set. Which is your PG data location. User home directory. Under that version directory, under that data directory is your PG data location. PG data is nothing but the location in which directories, subdirectories, and files are stored related to your Postgres database. Now, if you give ls, you can see many directories and files. One such directory is base. Base. So base is the location for your default location for your database files. Okay, so but not stored directly. They're stored within a subdirectory there with OID of the database. You got 3 databases. Each database has got its own OID, and that is what it is stored here. OID of your databases. We'll see them within database. Within this files will be stored. Within these files are stored, and this is the location. Echo $PG data. CD base. Okay. This is the location of your. If you go to one of these files, so for example, I'll go for the last one. So this is the location of your data files for one of the database, or you can take it as this is the location of your PG default for one of the database. Which is the database we'll see inside, because this object ID we don't know to which database it belongs to. We know that we got 3 default databases and we got 3 directories here. So each directory is for one database, and here we got 13830 is for a database. So this is the location of your PG default table space is nothing but OID of path of your database. So when we say PG default is the default location, PG default is the default location for your database, and this is the location for that. Now let us log into database and check for the informations. We have to connect as Postgres user, ensuring that our service is running. So it is always a good practice. Okay, check for the service Postgres 12. So it's running. Connect as Postgres user. So PSQL is the platform. So I don't give anything. PSQL is a Postgres SQL platform to connect and work with Postgres database. Just give enter. So whenever we give this, I'm not using any options. Default it has taken some of the options. Internally it is connecting as Postgres user, connecting to local host and default port, and also for default port. So we'll see what is the default port number, how to customize also we'll see later. Now we are connected to database. Here in the prompt, whatever it shows is not the user name, it is the database name. So you'll come to know that to which database you are connected. Here you connected as user, okay, and you are in Postgres now. This is your database name. So whenever you see hash prompt, you can recall this. In OS level also, hash prompt means what? Hash prompt means what? Root, super user. Same way, whenever you see within Postgres database name, and if you see hash, it is super user. You connected as super user. We'll see details. Now we are connected to platform, PSQL platform. So your first thing we'll check is which are those databases available. So here we can get help also. So \L, backslash is escape character actually. So you're giving L. L means list. Show me the list of databases. So how many databases we got by default? 3 databases are there. We got 3 databases: Postgres, template 0, template 1. What is the importance? We'll see. So if you want to get help, so you know that PSQL we got 2 options. We can use PSQL commands or options, and we can use SQL statements. \* will give you help of list of commands we can use. You can go through the list. We'll use some of the useful options. Okay, so we'll see which are those later. So these are the, okay, so for that you'd use question mark. Question mark means show me help. Show me the list of commands, options related to PSQL can be used against database. Now, if you give H, help, this is your SQL statement. Alter, okay, so drop, create. So all these are there. What are the SQL activity you can perform? So it is available. H. So if you want to quit, Q. PSQL if we are connecting to Postgres database. Okay, so now, so we'll go for one option, show data underscore directory. OS level it is your PG data. Database level it is data directory. Data directory under which your files are stored. So your PG data is your data directory. Under data directory, data files are there available for that actually. So here we got Postgres user. I can give DU, display users. Postgres user is a super user. Can create role, can create database. It's something like user is super user, can do anything. Can create database, can create other users also. Can create database, can create other users, means roles. Select OID, dat name from pg_database. Order by. I'm using SQL statement now. See, these are your PGSQL options commands. Okay, PGSQL commands. You will show also. Now I'm using statement. This first statement, this second one. Order by OID. So one is template 1. 13.829 is template 0. 13.830 is Postgres database OID, and that itself is the directory name under base. Means this indicates what? This is the location for files of Postgres database. So we got many files right here. This is the location for files of Postgres database. So let us go for word count. We have done this earlier also. We got 303 now. One more additional object is created. So whatever we are seeing here, object ID. So under data directory, we got base directory. Under base directory, we got object ID directory, which is nothing but location for Postgres database. Any objects of Postgres database will be stored in that location. Let us see the objects available. If I give DT, D means display, T means tables. We don't have any tables, no relations. No tables are available. Okay, so we'll see how to create and manage tables. Now we are in Postgres database. Let us connect to template 0 database. \C. C means connect. Database name. So database template 0 is not currently accepting connections. Now let us connect to template 1 database. So this is also database. That name is database name. Template 1. We are able to connect, and you are able to see that name here. So whatever you get is not user name. Instead, it is a database name. And hash prompt says that you are connected as super user. So now it is not allowing to template 0. What is the reason? Also I'll tell you. Okay, so and here it allows for template 1. Let us see. Object ID of template 1 is what? 1, right? 1, first one. 1. This is the location of your 1. So we'll go for word count. Let's show 303 files. Same we will go to location of 13.829. This is the location of template 0. We'll go for word count. So means we got same number of objects, right? Same number of objects are available. Means these objects, we didn't create even one object also. So these are the files related to objects. These are files related to objects. So this is the location for your Postgres database, location for template 0, template 1, because that is there with OID. Template 1 OID is 1. Template 0 OID is this. Postgres, template 1, template 0. Location for those three. Now let us look into creating database and using those databases for our purpose. What is the consideration with respect to that also I'll explain now. So now we have connected to database. So let us by connecting to any database, we can list the database available. We got 3 default databases. So you can switch to databases by or connect to a database by using C connect any database. So there are databases which will not be allowed to connect. We saw that. Okay, so we try to connect to template 0. So connections are not allowed. Template 0 we are able to connect. Name of the database can be any name. So and we check for the OID of the database also. Select OID that name from PG underscore database. So similar to as you got DB underscore, here we got PG underscore. Ordered by OID. So template 1 is 1, template 0. So this is our Postgres database. This is ID. Now let us create a database in a simple way. Okay, before to that, we'll go to OS path. So we got PG data environment variable wise data underscore directory within database. Under that base directory, we got 3 directories now. Let us create one more database. Create database. Create database, new DB. I'm not going to specify anything else. So we are not going to specify file. Obviously, we will not specify location. I'm not specifying. Which is the table space it uses. Even that we are not specifying. Means it uses PG default, PG underscore default table space by default. Now let us create a database by name new DB. We got only 3 databases. Now we are creating the 4th one. Got created. New DB got created, and this is the OID of that database. OID 16384. So if for every object that is created, not only database, you create any object, OID is generated. That OID is now 13384. So let us go to OS level and under PG data location, data directory location, base directory is the base for your files. Within that, you will have subdirectory by name. Name is OID name. Now you can see one OID is created. 16384 is nothing but your new DB OID is the directory name here. And within this directory, files are created. Which are those files? We will see. Okay, so let us go for word count. So 303, same number of files we have got in others. Actually, what will happen is, see, whenever we create a database, it's going to refer template 1 for creating itself. It's going to refer template 1 to create itself. Because of this, whichever the objects which are there in template 1 will be there in new DB also. So we'll see more about this. Example, now we created new DB, and when we created, we didn't specify anything. No objects were specified, but how come these many files are available which are related to objects? So these are related to objects. All these files are related to objects. How they are available is because internally, whenever we created a new DB, it has referred template 1 database is used as a reference to create itself. What are the specification this database has got is the specification of your new DB. That's why object ID of your new DB. So if you go to new DB location, all those files which are there in template 1 is also there in new DB. Objects wise, which are those objects available in template 1 is there with new DB. Files wise, which are the files which are there in ls. So we are checking for all files under 1, all files under 16384. So both it's showing 303 itself, because whatever there in directory 1 is also will be there in 16384, because it's going to refer, database is referred there internally. Means which are the objects which are there in template 1 is also there initially to start with. Now how to connect to new database? How to connect? So to check information, we can use PG database. I'm using only two informations, OID and dat name. So to connect to a database, \c new database, new DB, and still you are connecting a super user itself. Hash prompt is super user. So we are connected to new DB itself now. Can we create database with customized configuration other than whatever is there in specification wise? So yes, we can do. Yes, we can do. But initially, I'll go for same specification as the default one. So you must have connected to database as super user to any database. Doesn't matter. Then you can create other database. So we'll use the syntax for creating with some specification. So part of our database management. So now you know how to create a database. So monitoring wise, we are able to verify the informations. We'll manage it. Okay, further we can do a lot of administrative tasks. We'll drop it also when we don't need it. And you know that conceptually, when you say database, Postgres database available, you can create any database with any name. Apart from this, you'll have two other default databases, template 1 and template 0. So whenever you go for connecting, okay, so you're going to store objects. It goes to which location? PG database OID location. OID is nothing but object ID of your database. Any database, it need not be Postgres, any database, this is the default location. PG data environment variable. Within database, it is called as data directory location. Under that base directory, under that subdirectory name is same as your OID number. Within that files are stored. Within that files are stored. So in our case, we are seeing that okay, 303 files are stored. Now being client, we connect to Postgres service as which user? OS user, Postgres user, and from there we connect to database as Postgres user itself, database user. So DB username is Postgres and that user is super user. By connecting, can perform any type of activities which we are seeing. Once such is, we can create a database with whatever the name you want. With whichever the name you want, you can create it. Okay, so whenever you go for creating a database, it's going to use, okay, so template database. Which is the template database it uses is, it's going to use template 1. It's going to use template 1 for creating itself. So this template database will have default objects, and those objects which are there in template 1 will be there part of your our DB also. Our DB. So means while creating database, so we gave only name earlier. Okay, we gave a name only name earlier. So we can give any name. So if we give our DB, we'll take our DB. If we give new DB, we'll take new DB. Okay, so default database name is Postgres and owner is Postgres. When you create your database, you can give any name, new DB, our DB. Okay, so you can give any name. Now, template 0, it says that currently connections are not allowed. So there is an option saying that allow connections, true or false. While creating, we connected new DB and we connected. So means default value is true, allow connection true. Suppose if we set this to false while creating or later by altering, so then it will not allow connections. So in our case, template 0 is not allowing connections because this value is internally false actually for that. Allow connections true or false, allow connections to database or not. Connection limit, how many connections should be there done to the database? If you want only one connection by user, you can specify only one, or else you can give -1 unlimited. Give a value. If you say 5, only 5 connections can be happening to a database concurrently. Now here we got one more option, is template, true or false. Default is false. Means the database that you are creating will act as template database or database to be used by your users or application. That is what you have to decide. Now default value is false. Means is template false means it will be created as a database that can be used by users, applications to store their own objects. Suppose if you create as a template that can be referred by other databases to create themselves. What is the advantage? What is the advantage of is template? So assume that whenever we create any new database, so you know that now we are getting 302 or 303 objects or files. So those related objects are there. Now whenever a new database is created in our environment, we want 5 tables to be available by default, whichever is related to our application. So you create them in template database. Don't customize, modify default templates. Let them be as it is. Don't modify them. If you want to have a separate set of objects additional to your regular objects, then better create a separate database. Some like our template DB example. You can give any name. Our template DB. This says that it is your template DB which should be referred while creating database. Default, if you don't specify, it is going to refer which database? Template 1 to create it itself. But if you create a database, our template DB, you must specify is template true, will be used as template database. Don't allow connections initially, so you don't need to go do that, or else you allow connections also. And this database can have additional 5 objects. Example, in our case, additional 5 objects which will be created in each database you create later part, referring this database. Means which are the database you are creating, do you want that to be used for applications users or you want to maintain it as a template database? You have to decide that. Default, it can be used by users, applications. So if you use a template database, can they use it? They can use to create additional objects, but they should not use it for database activities. That's why you can make it as template database. So avoid altering the existing template databases. Instead of that, create your own template databases if you need them. For what? Why you need them? If you want to have additional objects, don't add them to default template. Instead of that, you create a separate database which will have base objects plus your own objects, both put together. You got default objects plus your objects. So will be used whenever a new database is created using this template database. So owner is Postgres. Now also we have to specify owner Postgres because we don't have any other users. Allow connections, true, it allows connections. Connection limit, unlimited -1. If you don't specify, default is unlimited itself. Is template false, it will not act as template database. Instead of that, it is a database that can be used by users and applications. So now Now, while creating database, you want to refer a template database. You want to refer a template database. Then there is an option called as template, refer it. If you don't specify this, default it uses which one? Template 1. Suppose if you specify template and if you say our template DB, it uses our template DB. Here it can be our template DB. So you can refer, if it is already there, our template DB, here you can give template name as what? Our template DB. So that whichever the objects which are there in that database will be there part of your new database that you are creating. Maybe you may give name as DSDB, new DB, our DB. You give whatever the name you want. You are creating that actually. So default it refers. Okay, default it refers template 1. Now if you want to make it to refer a different one, so assume that this is our DB. This is your template. So if you want to make it to refer, you have to specify that explicitly, so that it can refer and get created itself. Now encoding, which is that language you want to use, character set you want to use, UTF-8. If you don't specify, default is UTF-8 itself. And here you got LC collate. The way you want to collate means, you know that whenever, for example, whenever you go for creating a index, it has to do some sorting. So which type of sorting you should do, we can define that LC collate, which is not important, you can leave it default. For tables and indexes, for sorting operations, when you go for accessing your table sorting, or if you, when you create an index, it has to do sorting. What is that sorting method it should follow? So those things we can define it as LC collate. A mechanism is there available. And we can also specify table space which it has to use. Default, which table space our database will use? PG underscore default. You don't want to use PG default, so then you specify your own database, own table space. For example, new TBS. But this table space must be created. So table space must be available so that your database can refer and use it actually. Otherwise, if you don't specify default, it uses PG default. PG default is the default table space that is used by default. If you want to use a separate table space, name of the table space you specify. But this table space must exist. As of now, let us skip using table space. So we'll go for some options. Even if you don't specify with options, it uses default value. If you want to customize, you can customize and you can use non-default values also. So initially we'll go for custom, means instead of customing, okay, so we'll use the options with whichever the value it may use internally. Whichever the value it may use internally. So let me sum up the attributes. So owner, you can give owner name. As we got only Postgres user, we'll use Postgres only. Later when you create users, you can give that also owner for your database while creating it. Allow connections, true or false. It allows connections, users can connect. Otherwise it says that currently connections are not allowed. Default is true, it allows connection. Connection limit, -1 means unlimited. There's no limitation for connections. Is template, is this database used as template or not? True or false? Default is false. No, it is not used as template database. Instead, it is used as a database that can be used by users or applications. Suppose if you have to refer a template database which is having some specific objects specific to your database, you say template, name of the template database, name of the template database. For example, if you give a name as our template DB, use that name here. Encoding, UTF-8. So LC underscore collate is the way of collating your data. So particularly sorting operations on your tables and indexes is specified here. Table space, name of the table space which should be used by your database to store its objects. If you don't specify, it uses PG default table space. So these are some of the options. You give a name for your database, and also you can use other specification. Name is mandatory, rest of them they are not mandatory. Let us switch to server to perform database creation with custom options. So earlier we created a database without any other options. Just we said create database name. So that is sufficient. We are not specifying owner or template database connections, allow connections, or connection limits. We are not specifying any of those. You can specify them. But anyway, I'll go for the values which are almost default itself. So create database, name of the database with what are those options you want to use, you can decide. Owner. Owner is equal to, we got only one user, Postgres. I'll use the same user. So you can also specify encoding. So connection limit. So we can also go for allow connections true, something like this. Okay, we can use any options we want. So we are creating it now. So here I'm not specifying table space because we are not creating any custom table space. So allow connections we can alter also. We can do that later. Now we have created database by name DSDB. We can check that list will show DSDB is available. One is Postgres UTF-8 coding. Okay, so collection is also, it is taking US English UTF-8. We are not explicitly specifying it actually. So select okay, so here we can see we got created DSDB, and what is the object rate is 16385. Let us go to OS level. One more directory got created. So this is your location for a files of your DSDB database. So this is how we can create a database with some custom options also. Here, whatever the value I am using is the default values itself. Okay, default value. So select star from PG_score database where that name is equal to DSDB. So we are checking all details about our DSDB here. So you can also go for only selected one, OID, that name, that DBA, who is the owner, encoding, okay, DB collect. So all this we can specify. Now I'll use some of them. Is template, allow connections, connection limit, so let us clear the screen. Select OID, that name, that DBA, who is the owner, that is a template, allow connections, connection limit, table space. So it is prefixed with that. Okay, so that, so having that means it is related to database. So name is dat DBA. OID is 16.385. Dat name is DSDB. Dat DBS 10 is Postgres user. Easy template false. We are not created as template database. Allow connections true. Connection limit -1 means unlimited. Table space it is using 1663. 1663 table space is used. So we'll see more about table spaces later. Okay, we'll use it more later. So this is about database details. So we created a custom database now. We created a custom database.